From 5G networks to aerospace systems, from artificial intelligence to quantum technologies, from behind the scenes of innovations to real-world applications. Welcome to Innovations Unplugged, the Rohde and Schwarz technology podcast.
We are going to take a journey from our everyday digital landscapes to the rugged terrains of Mars. We'll take a deep dive into analog missions to Mars conducted by the Austrian Space Forum. These analog missions simulate life on Mars to prepare for future human exploration. My name is Inga Müller-Siedentop and I'm your host today. Joining us are two esteemed guests from the Austrian Space Forum. Among a lot of exciting things, they will share with us why a typical day on an analog mission begins with the installation of network technology from LANCOM Systems, a proud member of the Rohde and Schwarz family. As a child, Dr. Gernot Grömer dreamt of becoming either a helicopter pilot or a professional musician. Fast forward a few decades, he holds a doctorate in astrophysics, is a founding member and director of the Austrian Space Forum, and calls himself the dinosaur of the analog astronauts. Welcome, Gernot.
My gosh, you did a hell of a lot of research. I'm in between being embarrassed and proud.
I didn't know that about you. I'm quite. We'll talk about that later.
Brings us to our next guest. Her career reads like an adventure. Via training as a hairdresser, a degree in mathematics, and a doctorate in physics, Dr. Carmen Köhler finally became an analog astronaut. Welcome, Carmen.
Really happy to be here. Thank you.
Let's get started. Your path into space exploration really is one of a kind. So after graduating from school, you became a hairdresser. Chit-chatting with one of your clients, you found the courage to study mathematics and ended up getting a doctorate in physics. But this is not the end of your extraordinary story. You even became the first female analog astronaut at the Austrian Space Forum's Mars simulations. You are an AI and data expert. You are the founder and CEO of a company that specializes in weather and Earth observation data services. Quick question to begin with. Why? What drives you?
I think what drives me is curiosity. That I always think like, oh, why not, right? You can always try, and if you fail, you still learned. I think it's really interesting what we can learn in this life that we have at the moment. And I was always curious also about space. So what I really, really loved back then was a bit of media. I grew up without a television at first, but then it took over in the afternoons. And I really loved to watch Star Trek and MacGyver. And MacGyver, for me, was a total hero, and he was able to fix a fighter airplane with chewing gum, and things like that, and I thought that was absolutely amazing. And then Star Trek I really loved because of the whole universe and doing the exploration there and going from planet to planet and meeting different species, and I thought that was really interesting. And for me, always MacGyver on the Star Trek is kind of like an astronaut, and that's really what I wanted to be. And so when I finished my mathematics degree, I already saw that there was a position open for a PhD, which was together with Lufthansa and the Flight Security and the German Aerospace Center and the German Weather Service. And that was really amazing for me. And it was a project about how the aviation impacts climate with the contrails, not chemtrails, please. So I thought that was super fascinating. So I applied and they took me. And so I was working at the German Aerospace Center and was working also with at the German Weather Service and improving the numerical weather prediction model there. And it's something that I really noticed that it's my passion. And that's also why I founded my company amongst those topics.
I think your career is like a great point for some more screen time, Star Trek related. So, analog Mars mission. analog astronauts. So let's shed some light on this. What is an analog space mission? Why do we need analog astronauts? And why is Mars such a compelling focus for space exploration today? Gernot, would you mind?
When we go to Mars, it is the most ambitious and probably the most complex journey we've ever undertaken as humans. Like, just for comparison, the distance to the moon, where we went in the 60s and 70s, is like 380,000 kilometers. Mars can be away like 380 million kilometers. That's about a factor of 1,000. That means that given all the complexities for such a mission, there's probably around 1,000 ways how to die on Mars. And with this research, we maybe can figure out 800 of those. So we are there to mimic the challenges and opportunities, the strategies, the workflows, decision-making trees, technologies, materials, and so on, including the factor of the human factor, to see how you can conduct research on Mars. So what we're doing is, we're going to Mars-like locations on Earth, like Oman, like the Northern Sahara, like Israel, like the Caucasus, like last year. And we're deploying there a crew of very carefully selected analog astronauts, typically 6 individuals, highly trained, very carefully selected. They go there as the flight crew under quotation marks for typically 2 to 4 weeks, experiments pertinent to geoscience, robotics, human factors, under the supervision of a mission support center back here on Earth, and that is in Vienna.
Living in these Mars-like environments must present unique challenges. Carmen, could you take us with you on a typical day of an analog mission?
So one typical day on Mars, for example, in Armenia last year, is that we wake up at around 7, we have breakfast, and then we have the first meeting, the briefing, where we get like a daily activity plan and really discuss what we'll do during the day. So we always have 2 space simulators, and those 2 people are in this spacesuit simulator that day and conduct different experiments. So the interesting part is then that everybody has hands-on, because we're 6 analog astronauts, so you really have all hands-on during the donning, so putting on the suit, and that takes 2 hours. So we have 3 different layers of the spacesuit simulator, and everything has to be perfectly in place. The communication has to be in place. Everything is tested beforehand, because as soon as we go out, it's life-threatening. And then basically the experiments that are being conducted are sometimes also farther away, and that's why we also need the good network to be set up. And then normally it's 4 hours that you're outside conducting the experiments, and then you come back, and then you have the doffing that you take off the spacesuit simulator. And then we have a debriefing. We have to watch over the experiments, that everything is put in place. And also there we have different things to do. We have a lot for human factors, also where we have a lot of questionnaires. Also, if we took for geological samples, all of that has to be documented. All of the data is then sent also to Earth, also of course securely. and then we have dinner, and also then debriefing. And most of the time we then prepare for the next days or see what's open still. So that's a typical day on Mars.
Do you remember the first time you were packed in the suit?
Oh, I absolutely remember that. That was at a test version where we were at the Austrian Space Forum. It was during the training, and so we put it on, and it weighs around 50 kilos. So, and I knew that theoretically, but theory and practice is always something different. And then I put it on. I was like, okay, I need to go to the gym.
When we picture you as analog astronauts trekking through the deserts of the world or hiking on glaciers for several weeks, you're packed from head to toe. Everyone is in their spacesuits with huge helmets on their heads and backpacks loaded with high-tech gear. Gernot, in everyday life when we want to communicate, we just reach for our mobile devices. I guess on Mars and probably in a very terrestrial desert, mobile communication is not a given. So how did you solve the problem of communication and connectivity in the field? I assume this has to do something with LANCOM.
Yes. There are several aspects of this. Communication is not a given, but it's a necessity. It's vital to us. If there's one of the many things that are really dangerous in spaceflight is not knowing what's going on. So communication is as vital as oxygen to us. We know that if we are dropping communication between Earth and Mars, the Mars crew would be in a safe position for maybe a couple of hours or so, and then things start to disintegrate at a point. If there's a problem, they're on their own. There's nobody who can help them. So that applies to the habitats, the crews outside, the communication to Earth. So we need a super robust solution that helps us to maintain communication.
I think one crucial part is also that we were talking about the Mission Support Center a lot of times now, and also about the world's biggest analog. I think one important thing, and also with the communication, is that we have the communication on Mars in real time, but the communication to Earth is not in real time. And I think that is a huge part that is also worth pointing out here, because you have a lag, and you have a time delay when you have the communication. So that's why also the communication totally changes then between Earth and Mars, or simulated Mars, because we simulate a time delay of about 10 minutes in each direction. Mm-hmm. And normally it's around between 4 and 24 minutes in one direction, so that can add up until 50 minutes. But we decided to take the average of 10 minutes within the mission. And so that changes a lot of the things, which is also what I think really important to think about that with the communication, which is why it's not the mission control center. Like with Houston, we've got a problem. But it's when we say Vienna, we have a problem at the Mission Support Center, then they hear it 10 minutes later.
And the important thing, and this was one of the reasons why we had this long-standing conversations and cooperation with LANCOM, was you put it in, you plug it in, you power it up, and the thing works. And these are my favorite tools, where you don't have to think a lot. I've got a number of other things to be concerned with. It's not the communication. LANCOM is part of the critical infrastructure, bluntly speaking, and that's something that's a sticker you don't get so easily from Austrian Space Forum. We only allow things at the critical core systems when we fully trust them.
Let's dive deeper into what we are offering as a company. So to maintain our high quality standards, flexibility and reliability, Rohde and Schwarz covers a significant share of the value chain in-house. Most of our products are developed in Germany. LANCOM Systems and other subsidiaries in Germany and Europe complement the group's solution portfolio. Gernot, having this in mind, how important is it for a European-based analog mission like the ones of the Austrian Space Forum to rely on technology engineered in Europe?
It is about making sure what do we have and where do we have dependencies. And this is a topic that is, as a director of the Austrian Space Forum, and I'm speaking here with my personal opinion, this is not necessarily the opinion of the organization I represent, is that a European autonomy and sovereignty is not a luxury. And so having supply chains that are as independent as possible, that are resilient, that are technically at the edge of what can be done, are extremely important.
So on a broader scale, thinking globally, how do you think the relationship between European companies like Rohde and Schwarz and national space agencies around the world contributes to this?
Well, the work we're doing in the space field is always at the edge of what's technically possible. So some of the solutions we develop for going to Mars or staying in orbit and having their resilient satellite network might not be 100% necessary in everything we do on the ground. But it is the frontier where, because of the harsh conditions, the edge of being doable is an innovation driver. So there is both a lot of spin-offs, where we have technologies developed for space that are used here on Earth, spin-ins that go the other way. We have one of the most important innovation drivers every day in front of our faces, and that's necessity. The necessity to be resilient, to be top of the game, to be robust. A value we both share with LANCOM and the Austrian Space Forum. As a personal background story to this, we've been asked a few times before, why did we choose LANCOM? There are other providers that maybe the brands are maybe more well known because they're bigger players, whatever. And we said, well, It might be that the router from the other company might do the same job, but it's also about the culture of the company, the flexibility, this innovation-driven mindset. This is a partnership that goes beyond a brand. And that's, as always, it's always about the people.
So, Carmen, you also worked with the technology, with a network setup, giving these surroundings, these settings, the conditions for network technology in a Mars simulation must be really unusually harsh compared to a standard office environment for a Wi-Fi connection as we know it. What do we have to imagine? Which situation left the greatest impression on you thinking about the weather conditions or circumstances surrounding the technology?
The Mars-like regions on Earth are per definition extreme environments. So we will meet extreme conditions. And I have one situation in mind in Oman, for example, where we had a sandstorm. And then we have to totally cover up. That was the point where we were still allowed to exit the habitat without the spacesuit simulator. And so, but we had to totally cover up. We had the ski goggles, like we were going against the sandstorm. And then we had to make sure, of course, with the antennas that everything is fine. And those situations you really keep in mind. No? We had to really make sure that everything is fine. And in general, when we knew that there was a lot of wind, that we had to kind of see that the technology is safe. Not only the humans, but also technology is absolutely crucial. We want to survive with it on Mars, right?
The camels in Morocco were finding out quite quickly that the heating element of the LANCOM routers is quite warm. And if it's in February, it's very cold. So they started to rub their shoulders on the routers. And although we had pinned them down, they were able to top them over. So we had to station somebody from our Moroccan partners to guard the routers during the night when it's a bit of cold and shy the camels away. Yeah.
The Austrian Space Forum specializes in Mars missions, in analog Mars missions, but there's something even bigger coming up this year.
Oh,
Could
yeah.
you share?
We've been doing this for 20 years now. And just to give you a sense of the scale here, when we go to a desert, we have typically people from like 25 nations, more than 200 researchers, medical doctors, engineers, psychologists, and so on. So these are pretty big projects already. But we say we can go one step beyond that. And there is a project called the World's Biggest Analog. And I know it's kind of a weird name, but it really hits it on the spot. Because it means that when we are looking globally, there are other groups that are operating habitats for lunar exploration, Mars exploration, spacecraft in transit, for instance. So we are teaming up with habitats across the world, from Brazil to Portugal, from the Caucasus to India, from Kenya to Oman, from Poland to wherever. And we say, what about a future where we're not talking about the first human robotic mission to Mars anymore? But what if we project the future like 20 years afterwards, when we have like half a dozen of stations on the moon, half a dozen of stations on Mars, a spacecraft in transit? This is going to be a huge operational challenge. If you just think of how many people you need to devise the flight plan for an astronaut on the International Space Station, and now we're talking about like what, 70, 100 astronauts or so. And we are having the Mission Coordination Center, as we call it, in Vienna, which is at the center of the eye of the storm. That means we're trying to figure out what is the best, schedules, managing science data, looking into weather predictions, a lot of services we provide here. So we'll be mentally on at least 2 planetary bodies at the same time, having to jump mentally from one station to the other in, 4 continents, a half a dozen time zones, and still have situation awareness. I can promise you what's going to happen in October, second half of October. It's going to be a mess, but it's going to be a necessary mess, because we need to figure out where are the strengths of our plannings, where are the weaknesses. And that's exactly what we do as the Austrian Space Forum. We have this development mantra of fail fast, fail cheap, but have a steep learning curve. And that's exactly what we're going to practice to the biggest extent we can imagine. I'm both excited and scared and anxious, but also I see there's so much potential in these type of missions that October is going to be a blast.
Great. Thank you for sharing. We're coming to an end, but I do have two last questions. Quick question, quick answer kind of thing. Gernot, when will humans step their foot onto Mars?
Our current projections say within the next 20 to 30 years, which means if we assume the person who will walk on Mars will be around, let's say, 40 years, more on the experienced side or so, it actually means that the very first humans to be walking on Mars are already born or just attending an elementary school in Beijing, a high school in New York, who knows. So the very crew for this most ambitious journey, the most complex endeavor we've ever undertaken as a society, this crew exists already. They just don't know it yet.
Carmen, you are not the one who's graduating from school right now, but what is your expectation talking about flying to Mars? Is that something that's still in your mind?
I wouldn't call it an expectation, it's more a dream. And I definitely dream about going to space. I would love to go on another planetary body. If it's not Mars, I would love to go to the moon, especially because I love Earth so much in the atmosphere as well. And I would love to see the Earth from the moon, because we have to think about when we travel to Mars, we only see the Earth like we see Mars from here, right? So from here, Mars is a small red dot. And so when we're on Mars, Earth is a pale blue dot. It's also a book, which is very good. But so my dream is still going to space, to the moon or to Mars, yes.
Fascinating to see how technology, and in this case, technology engineered in Europe, is already paving the way for future space exploration. Thank you, Carmen. Thank you, Gernot, for being with us and sharing your insights.
Our pleasure.
Thank you, Inga.
And thanks to our listeners for tuning into this episode. If you enjoyed it, leave us a like and join us next time as we continue to explore technologies shaping our world and even beyond, as we learned today.